Shop the Plato's Closet Black Friday event in North Charleston and West Ashley and let the deals begin. You know Plato's Closet always has a huge selection of trendy recycled styles at amazing prices, but Black Friday deals are different. They're better. We've been holding back some of our best inventory, and you won't want to miss our Black Friday event. Save on gently used styles from Patagonia, Lululemon, Lilly Pulitzer, and hundreds of popular brands. Plato's Closet is ready to let the Black Friday deals begin. Plato's Closet, located in West Ashley on Sam Rittenberg Boulevard and North Charleston on Rivers Avenue.
Hello, saver. Whether you're saving for that trip to the tropics or saving for an emergency, now is the time to take advantage of Wells Fargo's savings options. Wells Fargo offers savings accounts that can help you save towards your goals. So, what are you saving for? Visit a Wells Fargo branch or wellsfargo.com/save to open a savings account today.
Wells Fargo Bank, N.A., member FDIC.
This is SpaceTime, Series 22, Episode 91, for broadcast on the 11th of December 2019. Coming up on SpaceTime, discovery of the biggest supermassive black hole in the local universe, the sun's secrets being revealed by NASA's Parker Solar Probe, and determining the size of a proton. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have identified a record-setting supermassive black hole, some 40 billion times the mass of our Sun, making it easily the biggest in the local universe. The monster is located at the centre of Holm 15A, an elliptical galaxy at the very heart of the Able 85 galaxy cluster, some 700 million light-years away. Able 85 contains an estimated 500 individual galaxies. The findings, reported in the Astrophysical Journal and on the prepress physics website archive.org, will help astronomers studying even more distant supermassive black holes and the galaxies therein. The Holm 15A galaxy has the enormous visible mass of some 2 trillion solar masses, but the centre of the galaxy is extremely faint and diffuse. And the study's lead author Jan Thomas from the Max Planck Institute says it was that feature which sparked the team's interest in the first place. See, the central diffuse region in this galaxy is about the same size as the Large Magellanic Cloud, a satellite galaxy of the Milky Way. And that's what raised suspicions that an unusually large supermassive black hole might exist deep inside. There have only ever been a few dozen direct mass measurements of supermassive black holes, and never before has this been attempted at such a distance. Thomas and colleagues evaluated photometric data of the galaxy obtained using the Wendelstein Observatory and then combined that information with new spectral observations by the European Southern Observatory's Very Large Telescope in Chile. The new data allowed the authors to perform a mass estimate based directly on stellar motions around the core of the galaxy. The light profile of the galaxy shows a centre with an extremely low and very diffuse surface brightness, much fainter than in other elliptical galaxies. And the light profile in the inner core is also very flat, which suggests that most of the stars must have been expelled from the centre through some sort of interactions in previous mergers. The commonly accepted view is that the cores in such massive elliptic galaxies form through a process known as core scouring. In a merger between 2 galaxies, the gravitational interactions between their merging central black holes leads to gravitational slingshots that eject stars on predominantly radial orbits from the centre of the remnant galaxy. And if there's no gas left in the centre to form new stars, as there would be in younger galaxies, then that leads to a depleted core. Thomas says the newest generation of computer simulations of galaxy mergers has given the team predictions which absolutely match the observed properties they're seeing. These simulations included interactions between stars and a black hole binary. But the crucial ingredient are 2 elliptical galaxies that already have depleted cores. This means that the shape of the light profile and the trajectory of the stars contain valuable archaeological information about the specific circumstances of core formation in this galaxy, and it can also be applied to other very massive galaxies. The good news is, even with this unusual merging history, the authors could establish a new and robust relationship between black hole mass and galaxy surface brightness. So with every merger, the black hole gains more mass, but the galactic centre loses more stars. And all that can be extrapolated to other galaxies as well. You're listening to SpaceTime. Still to come, the first detailed results of NASA's Parker Solar Probe are revealing some surprising secrets about the Sun. And a SpaceX Dragon cargo ship carrying what could only be described as a garage for robots has successfully docked with the International Space Station. All that and much more still to come on SpaceTime. The first detailed results from NASA's Parker Solar Probe are revealing some surprising secrets about our local star, the Sun. The dramatic details reported in 4 new papers in the journal Nature are opening a window on previously unknown and only theorized characteristics about the Sun and how stars form and evolve throughout the universe. The newly revealed data describes the probe's unprecedented near-Sun observations through its first 2 record-breaking close flybys. During these initial flybys, Parker studied the Sun from a distance of just 24 million kilometres. Now that's much closer to the Sun than the planet Mercury. But the spacecraft will get even closer in future orbits as it travels at over 343,000 kilometres an hour. That's much faster than any other spacecraft ever. One of the key features being observed is the solar wind, the constant stream of ionized material being pumped out of the Sun. This flow of plasma fills the entire solar system, and it interacts with Earth's magnetic field, triggering what we term space weather events. Now, these events are important because they can destroy or at least damage spacecraft. They can black out terrestrial power grids, scramble communications and navigation systems, both in space and on the ground, and increase radiation exposure for both astronauts and even people on airline flights. The Parker Solar Probe has provided new insights into the processes which are driving the solar wind and how it couples with solar rotation. The unprecedented observations have shown that instead of the constantly relatively uniform outflows seen from Earth, the Sun's solar winds are actually very dynamic and highly structured, similar to an estuary serving as a transition zone as a river flows into the ocean. For the first time, scientists have been able to study the solar wind from its source, the Sun's corona, similar to how one might observe a stream that serves as the source of a river. This is providing a very different perspective compared to studying the solar wind where its flow impacts the Earth. Scientists also detected strange, unexpected events they're calling switchbacks, where the direction of the Sun's magnetic field embedded in the solar wind suddenly flips. These reversals appear to be a very common phenomenon in the solar wind flow inside that of the orbit of Mercury, lasting anywhere from a few seconds to several minutes as they flow over the spacecraft. Yet they seem not to be present any further out from the Sun, making them undetectable without actually directly flying through the solar wind, as Parker has done. During a switchback, the magnetic field whips back on itself until it's pointed almost directly back at the Sun. These switchbacks, along with other observations of the solar wind, may provide some early clues about what mechanisms are actually heating and accelerating the solar wind. Not only does such information help change science's understanding of what's causing the solar wind and space weather affecting the Earth, it also helps researchers understand fundamental processes about how stars work and how they release magnetic energy into their environments. This information will be vital to protecting astronauts and technology in space, an important part of NASA's Artemis program, which will see humans return to the Moon in 2024 and eventually onto Mars and beyond. Meanwhile, measurements of solar wind particles, including electrons, protons and alpha particles, which are composed of 2 protons and 2 neutrons tightly bound together, has found some surprising clues about how the Sun's rotation affects the outflow of the solar wind. Near Earth, the solar wind flows past our planet as if it's initially travelling in almost straight lines. In other words, radially, sort of like the spokes on a bicycle wheel, out from the Sun in straight lines in all directions. But the Sun rotates as it releases the solar wind, and before it breaks free, the solar wind's expected to get a push in sync with the Sun's rotation. As Parker ventured to a distance of around 32 million kilometres from the Sun, scientists obtained their first observations of this effect, finding the sideways motion was much stronger than predicted, but also transitioned far more quickly than expected into a straight, strictly outward flow. This enormous extended atmosphere of the Sun will naturally affect the star's rotation, so understanding the transition point of the solar wind is key to helping understand how the Sun's rotation slows over time, and that has implications for the Sun's life cycle as well as its potentially violent past. It can also be extrapolated for other stars and for the formation of protoplanetary disks, those dense disks of gas and dust surrounding young stars out of which planets are eventually formed. Parker also observed the first direct evidence of dust starting to thin out around 11.3 million kilometres from the Sun. That's an effect that's been theorised for nearly a century, but it's been impossible to measure until now. You see, scientists had long suspected that close into the Sun, the dust would be heated to such high temperatures it would be turned into a gas, resulting in the creation of a dust-free region around the star. At the observed rate of thinning, scientists expect to see a truly dust-free zone beginning at a distance of around 4 million kilometres from the Sun, which the spacecraft might observe in September during its 6th flyby. That dust-free zone would signal a place where the material of the dust has been evaporated by the Sun's heat to become part of the solar wind flying past Earth. Finally, Parker measured several never-before-seen solar energetic particle events so small that all traces of them are lost before they reach Earth, some 150 million kilometres distant. It observed a rare type of particle burst with an especially high ratio of heavier elements, suggesting that these events may be more common than scientists had previously thought. Solar energetic particle events are important because they can arise suddenly and lead to space weather conditions near Earth that could be potentially very harmful for astronauts. So, unravelling the sources, acceleration and transport of solar energetic particles will help scientists better protect humans in space in the future. This report from NASA TV.
Traveling through the Sun's blazing hot atmosphere, NASA's Parker Solar Probe has sent back a complex, close-up view of our star. The spacecraft confirmed that our picture of the Sun from Earth is deceptively simple. Parker is the closest spacecraft to the Sun, meaning we now have never-before-seen details about the solar wind and solar energetic particles. Solar energetic particles are high-energy particles that can endanger both astronauts and satellites in space. The solar wind is the continuous outflow of particles and magnetic field from the Sun. Both speed out, filling up space, and affecting space weather throughout our solar system. For the first time ever, we were able to go to the source of the solar wind and solar particles. Here are 5 features Parker saw. We've long known that space is full of cosmic dust. We can even see the dust from Earth because it reflects sunlight. Parker saw evidence that the dust stops at an estimated 3.5 million miles from the Sun. As the dust gets closer, the Sun vaporizes it, creating a dust-free zone surrounding the star. At Earth, it appears that the magnetic field lines flow evenly out from the Sun, but Parker saw them behave in a surprising way. The magnetic field lines flip in a whip-like motion, turning 180 degrees around in a matter of seconds. These switchbacks came in clusters and were timed with fast-moving clumps of plasma in the solar wind. Scientists have long wondered if the solar wind is generated as a continuous flow or in spurts. We now see evidence that the solar wind has rough, irregular texture. The plasma within it also seems to lack an orderly sense of direction. Some clumps of solar material fire out into space, while others fall back toward the Sun. These clumps may be distorting the magnetic field, causing the switchbacks. They may also be an indicator of what the solar wind looks like in its early stages after its birth on the Sun. Parker found a transition point in the solar wind. The corona is the Sun's faint, outermost layer that transitions to the solar wind. Before Parker, scientists knew that the corona rotates with the visible surface below it, but they didn't know how, or where, the solar wind switched to flowing straight by the time it reaches Earth. Parker has finally spotted signs of this transition, and the changeover happened significantly farther out than expected. Although the Sun has been very quiet over the first 2 orbits, Parker observed several tiny bursts of solar energetic particles. While these events have been seen before, never ones this small. The fast-moving particles from these modest bursts spread out as they move from the Sun, making them undetectable from Earth. Without Parker's front-row seat, we would never know that the Sun is regularly producing these small-scale events. Fast-moving particles are a source of dangerous radiation. The more we learn about these eruptions, the better we can protect our technology and astronauts. Parker still has more work to do, but it's already helping us see our star in a whole new light.
Physicists are getting closer to finally solving the proton radius puzzle, with one of the most precise new measurements of the charge radius of the proton. The new value for the proton radius is 0.831 femtometers, which is significantly smaller than the previous electron scattering value of 0.88 femtometers. Importantly, these new findings, reported in the journal Nature, are in agreement with recent muonic atomic spectroscopy results. The research was carried out by physicists with the PRAD collaboration at the United States Department of Energy's Thomas Jefferson National Accelerator Facility. It's the first new method in half a century for measuring the size of a proton through electron scattering. So why is this important? Well, all visible matter in the universe is made out of protons, each of which is composed of three elemental particles called quarks. These quarks are bound together by the strong nuclear force mediated by a force particle called a gluon. And so the ubiquitous proton sits at the very heart of every atom. And because of this, it's been the subject of numerous studies and experiments aimed at trying to reveal its secrets. What we can say is that you shouldn't be thinking of protons as single hard spheres. Think of them more as itsy-bitsy clouds. But they're clouds filled with mystery. In fact, an unexpected result from an experiment to measure the size of this cloud in terms of its root mean square charge radius has united atomic and nuclear physicists in a flurry of activity to re-examine the basic quantity of the proton. Prior to 2010, the most precise measurements of the proton's radius came from two different experimental methods. One involved electron scattering. This involved electrons being shot at protons and the proton's charge radius being determined by the change in path of the electrons after they bounce off or scatter from the proton. The other method is atomic spectroscopy. It measures transitions between energy levels by electrons in the form of photons that are given off by the electrons as they orbit a small nucleus. Nuclei which have typically been observed in these measurements include hydrogen, which has a single proton in its nucleus, and deuterium, a heavier form of hydrogen, which has a nucleus comprising a proton and a neutron bound together. These two different methods, electron scattering and atomic spectroscopy, have both yielded a radius of around 0.88 femtometers. But then in 2010, atomic physicists announced the results from a new method. They measured the transition between energy levels of electrons in orbits around lab-made hydrogen atoms that replace the orbiting electron with a muon, a more massive elemental particle similar to an electron which orbits much closer to the proton and is more sensitive to the proton's charge radius. And this yielded a different result, a value some 4% smaller than before, about 0.84 femtometers. Then in 2012, a collaboration of scientists came together at Jefferson Lab to revamp electron scattering methods in hopes of producing a novel and more precise measurement of the proton charge radius. The collaboration instituted three new techniques to try and improve the precision of the new measurement. First was a new type of windowless target system, which flowed refrigerated hydrogen gas directly into the stream of accelerated electrons and allowed scattered electrons to move nearly unimpeded into the detectors. So what's all this windowless mean? Well, in electron scattering, a window is a metal cover at the end of the tube. But windowless means the metal cover's been removed, hence the term, and the tube is therefore open to the vacuum of the accelerator. The next major difference was the use of a calorimeter rather than the traditionally used magnetic spectrometer to detect the scattered electrons resulting from the incoming electrons striking the hydrogen's protons and electrons. The calorimeter measured the energies and positions of the scattered electrons, while a newly built gas-electron multiplier detected the electrons' positions with greater accuracy. The data from the detectors was then compared in real time, which allowed the authors to classify each event as either an electron-electron scattering or an electron-proton scattering. This new method of classifying events allowed the team to normalize their electron-proton scattering data to electron-electron scattering data, thereby greatly reducing experimental uncertainties and increasing precision. The last major improvement involved the placement of these detectors extremely close in angular distance, less than a degree, from where the electron beam strikes the hydrogen target. See, electron scattering requires a smaller scattering angle as possible in order to extract the proton radius. The authors say their results are unique because it used a new technique through electron scattering to determine the proton charge radius. They'll now compare their results to new spectroscopic determinations of proton radius and upcoming electron and muon scattering measurements. Importantly, the findings also seem to have shut the door on conjecture of a possible new fifth force in nature, which had been proposed when the proton radius puzzle first surfaced. When the initial proton radius puzzle came out in 2010, there was speculation that this might have provided evidence of a possible fifth force in nature, a force which acts differently between electrons and muons. But based on the new results, that now seems unlikely. You're listening to SpaceTime. Still to come, a Dragon cargo ship carrying what could be best described as a garage for robots has successfully docked with the International Space Station. And later in the science report, the World Meteorological Organization says 2019 is wrapping up a decade of exceptional global heat, retreating ice sheets, and record sea level rises. All that and much more still to come on SpaceTime. Okay, let's take a break from our show now for a word from our sponsor, the Great Courses Plus. You know, sometimes we all need to take a break from that constant news cycle. And that's where the Great Courses Plus comes in. Not only is it a great escape, it's empowering as well, because with this new streaming service, you get to pick up a new hobby or build on your knowledge on virtually any topic you want, such as the science of evolution or great palaces of the ancient world. And there are how-to courses on everything from painting to cooking, even how to play a musical instrument. In fact, there are literally thousands of fascinating lectures to explore, all of them presented by top-line experts in their field. And the best part about the Great Courses Plus is that you can escape into this vast world of knowledge anywhere, anytime, on the way to work, while whiling away the hours on a lazy afternoon, before you go to bed at night, or on that long-haul flight. As I mentioned last week, I've been enjoying this new series from the Great Courses Plus called Skywatching, Seeing and Understanding Cosmic Wonders, taught by Professor Alex Filipenko. With this course, you'll learn everything you need to about looking up into the sky, be it day or night. For example, most people are aware that when they look at stars, they're actually looking at what the stars were like in the past, hundreds or even thousands of years ago. That's because the stars are hundreds or thousands of light years away. But even our sun, we're not seeing what it's like now, we're actually seeing what it was like 8.3 minutes ago. And did you know that as the moon continues to slowly drift away from the Earth, total eclipses will become more and more rare and they'll be shorter? In fact, in about 500 million years from now, total solar eclipses from Earth will no longer be possible. And Alex Filipenko will explain exactly why this happens. You'll learn the orbital mechanics of the sky. So that's Skywatching, Seeing and Understanding Cosmic Wonders. And as a SpaceTime listener, the Great Courses Plus have a wonderful special offer for you. If you sign up with the Great Courses Plus, you'll get an Access All Areas free trial to the entire library. Empower yourself with knowledge and sign up today with the Great Courses Plus. But in order to get our special offer, you'll need to sign up through our special URL. Just go to thegreatcoursesplus.com/space. That's thegreatcoursesplus.com/space. And of course, we'll have that URL and the details in the show notes and on our website. That's thegreatcoursesplus.com/space. And now, it's back to our show.
You're listening to SpaceTime with Stuart Gary.
A SpaceX Dragon cargo ship carrying what can only be described as a garage for robots has successfully docked with the International Space Station. The Dragon CRS-19 mission had launched 2 days earlier aboard a Falcon 9 rocket from Space Launch Complex 40 at the Cape Canaveral Air Force Station in Florida. The Falcon 9 first stage later successfully landing on the drone ship, Of Course I Still Love You, which had been pre-positioned downrange in the North Atlantic Ocean.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Engines ignition. Liftoff of the Falcon 9 and Cargo Dragon, transporting critical research to enable living and working in Earth orbit and in deep space.
Vehicle supersonic. Vehicle has reached maximum aerodynamic pressure.
Recovery AOS.
Evac engine chill.
It's a call for chilling the second stage engine.
Eco. Evac ignition.
Stage 1 boost back burn is starting.
So very significant calls there. Successful separation of the first stage from the second stage, active and taking Dragon towards its correct orbit. And we saw the boost back burn begin, and so the Falcon is headed towards the drone ship there again off the coast of Jacksonville.
Stage 1 boost back burn is shut down.
That's a nominal jettison of the nose cone. The hypersonic grid fins expanding to help steer essentially this rocket towards the drone ship.
Trajectory.
Acquisition of signal Bermuda.
The primary objective today is to get Cargo Dragon to its correct orbit, and the secondary objective is to recover that Falcon booster
landing on Of Course I Still Love You, about 185 nautical miles off the coast of Jacksonville.
Stage 2 continues on nominal trajectory.
Again, we use that term nominal. That essentially just means that we're within the expected and appropriate range where we should be. So that all that means is that everything is going according to plan. All right, so a lot of work done, a lot more to go. We are still not there yet. We have to kind of progress through the spacecraft deploy, solar array deploy, and check out to make sure everything is in good order.
In order to land our drone ship in the Atlantic Ocean, the first stage needs to execute a series of 3 burns. The first is a boost back burn, which is meant to slow the rocket down and reorient it for re-entry. That just completed a few seconds ago. Next is the entry burn, where Falcon 9 slows itself down before hitting the dense parts of the atmosphere. Without this second burn, relying solely on the atmosphere to slow down Falcon 9 will put unnecessary strain on the rocket. The third and final burn is the landing burn, which happens just before touchdown. It provides the booster a soft descent to attempt landing, and this is also when the 4 landing legs were deployed. For this final burn, Falcon 9 uses just a single Merlin engine, the center engine, engine number 9. The second stage, continuing its journey into orbit.
Stage 1 landing burn has started. Acquisition of signal, New Hampshire. Stage 1 landing legs have deployed. Stage 1 has landed. Recovery operators.
And touchdown of Falcon 9 on our drone ship. Of course, I still love you. You can certainly hear the excitement here at SpaceX. Congratulations to the entire SpaceX team for another successful landing. For those keeping track, this is first stage recovery number 46. Back to our primary mission, the second stage is still continuing its journey into its desired orbit. We should be hearing callouts for second engine cutoff very shortly here. And good second engine cutoff. Now we're waiting for callouts of a good orbit. It sounds like we do indeed have a good orbit. Up next is deployment of Dragon from that second stage. And there it is, successful deployment of the Dragon spacecraft. Dragon deployed, the next major milestone will be deployment of the solar arrays as Dragon makes its way to the International Space Station.
Dragon now flying free. Solar arrays deploy from the sides of the Dragon trunk. It'll eventually give Dragon a wingspan of about 50 feet, a little more than that. And this is actually one of the last few times you're going to see these solar array deploys on a Dragon spacecraft. As they are deploying, there are some additional moving parts in them as compared to the new Dragon design and the Crew Dragon, where those solar cells are actually wrapped around the trunk itself. That does cut down on a few moving parts, some of the things that the engineers have to check out, all the screws, bolts, things like that, and also the lock nuts, just making sure everything that's in place, they'll actually be integrated into the trunk itself for those future Dragon missions. And they're going to be switching over to that Dragon type once they start their CRS-2 contract deliveries, which is slated for CRS-21. We've been hearing some updates from the visiting vehicle officer here in Mission Control. Everything so far has looked great with this Dragon so far.
The Dragon is deploying its solar array.
And we did get some audio confirmation that the solar array deploy has begun.
Dragon's propulsion system is successfully primed and all thrusters are ready for firing.
One set of the solar panels deploying. Again, one on each side of Dragon's trunk, giving a wingspan of about 54 feet once fully deployed, providing all of the electrical power to Dragon systems as it makes its chase down of the International Space Station. And everything looking smooth. We'll wait for some audio confirmation that the solar arrays have deployed successfully.
Expected loss of signal, New Hampshire.
The solar arrays have been deployed successfully. The propulsion system on Dragon being primed for some initial firings. Again, Dragon's going to be gradually raising its orbit over the next 2.5 days, until it arrives at the International Space Station.
The Dragon was carrying some 2,586 kilograms of food, supplies and scientific experiments for the Expedition 61 crew aboard the orbiting outpost.
Wells Fargo presents one of the surest ways to grow your money. A Wells Fargo CD account, where you can earn a 5.00% annual percentage yield on an 11-month term with a minimum opening deposit of $5,000. Visit a Wells Fargo branch or wellsfargo.com/CD rates to open a CD account and start growing your savings with us.
Wells Fargo Bank, N.A., member FDIC.
These included some 977 kilograms of equipment for science investigations, 256 kilograms of fresh crew supplies, 306 kilograms of space station hardware equipment, 65 kilograms of spacewalk equipment, 15 kilograms of new computer resources, and 942 kilograms of external payloads, including a new lithium-ion battery pack to replace one that failed, and a new generation hyperspectral Earth imaging system which will eventually be attached to Japan's Kibo module. It's designed to undertake space-based observations of land use activities, resource development, and monitor environmental changes on the Earth's surface. Scientific experiments transported by Dragon include studies on malting barley in microgravity, the spread of fire in space, and research on bone and muscle loss. Dragon's also transporting a robotic tool storage docking station that allows robotic external leak locator units to be stored outside the space station, making it quicker and simpler to deploy the instruments. The leak locator is a robotic remote-controlled tool that helps mission operators detect the location of an external leak and then rapidly confirm a successful subsequent repair. These capabilities can be applied to any place where humans live in space, including NASA's proposed new Lunar Gateway space station, which should be operational by 2028, and eventually habitats on the Moon, Mars and beyond. This is SpaceTime. Coming up next, a look at the 2020 Australasian Sky Guide. And later in the science report, you may not think cats' faces have expressions, but they do, and there are some people who are really good at deciphering the subtle differences in a cat's face that reveal their mood. All that and heaps more still to come on SpaceTime. The 2020 Australasian Sky Guide has been released, providing stargazers with everything they need to know about the southern night skies and tips on how best to view them. Highlights for next year include supermoons in March and April, a partial eclipse of the sun in June, and a blue moon in November. The guide's author, Dr. Nick Lom, consultant curator of astronomy at the Powerhouse Museum Sydney Observatory, says this latest and 30th edition of the guide includes more historical features and astronomical details while still retaining the same compact format.
So it's been going since 1991. Every year it gets a little bit better than the previous year. This year it has expanded number of pages. It has colour images like we have had for the last few years, and I'm very pleased the way it looks. It's a guide to the night sky. It's written for people around Australia. There is no prior astronomical knowledge assumed, so it's written as simply as possible with explanations. The emphasis is on city dwellers, what can be seen from cities, because of course most Australians live in cities, so the emphasis is very much what can be seen from cities. I always tell people that light pollution is bad, but it has just one advantage. It's the fact that you can get to know the main features of the sky better from a city than from a country, because light pollution, exactly, because it's the only things you can see. So you can see the Southern Cross and Orion and the main features.
Well, you can see a bit of the Southern Cross. There's one star that's sort of gone now, so the Southern Cross is sort of no longer the way it used to look.
Well, exactly. But you can still see most of it, and so there's still quite a lot that you can see from cities. Planets, especially, you can see the motion of the planets, and of course you can see the moon. And next year, and that's one of the things that's included in the Sky Guide, is there are a number of events associated with the moon. There are a couple of what I call supermoons. That's not really a term that astronomers like, but it has become accepted. And that's when the moon, full moon, happens to coincide with the time that the moon is closest to Earth, because the moon has an oval-shaped path around the Earth. It varies by about 40,000 kilometres, so it's closest at 363,000 kilometres and furthest at 405. So when a full moon happens to coincide with the moon being at its closest, that's referred to as a supermoon, and it appears a little bit larger in the sky. So there are two events, two supermoons. There's also a blue moon in November. The current definition of a blue moon is if there are two full moons in a month, and in November there will be two full moons, with the second one referred to as a blue moon. So it's sort of a bonus full moon for the months. There are other interesting events in 2020. The most exciting and most interesting is a conjunction of Jupiter and Saturn. They're the two giants of the solar system, and they will be very close together in the sky in December, in late December. They'll only be separated by 6 arc minutes, which is 1/5 of the diameter of the full moon. And that should be a very spectacular event. We should just be with the unaided eye. We could just make out the two objects as being separate. And then with a small telescope, we could see Jupiter and Saturn with their moons intermingled. So it should be a very spectacular sight.
And of course, before all that, this month, December 2019, we have a partial eclipse of the sun visible from Darwin.
That's right. Unfortunately, the rest of us missed out on that, so only people in Darwin, this partial eclipse of the sun.
And the 2020 Sky Guide also covers the anniversary of Captain Cook.
That's right. That's the 250th anniversary of Captain Cook arriving in Australia. Now, a lot of people incorrectly say that Captain James Cook discovered Australia, which of course he didn't. It was very well known to the indigenous people who actually lived in the country. It also had most of Australia had already been mapped by the Dutch. And in the Sky Guide, I include a map published in 1663 based on the exploration of the Dutch explorer Abel Tasman. And Australia is quite recognisable. But what is missing is the east coast, and that's what James Cook mapped. James Cook, captain of the ship the Endeavour, was coming back from Tahiti.
And of course, this whole mission was actually an astronomical mission to start with.
That's correct, because he had been originally sent out, the whole ship, the Endeavour, with Captain Cook and his astronomer Charles Green, was sent out to observe the transit of Venus from Tahiti. Tahiti was an ideal spot to observe the 1769 transit of Venus. This is when Venus crosses in front of the Sun. It happens roughly twice a century, 8 years apart. Happened in 1761, happened again in 1769, and it was extremely important to scientists because it was a way of measuring the distance from the Earth to the Sun by exactly timing how long Venus took to pass in front of the Sun. It was a way of measuring the distance from the Earth to the Sun, and that gave the whole scale of the solar system, and that was the whole basis then. And in fact, of course, the distance from the Earth to the Sun still gives the basis not just of the solar system, but a whole idea of the solar system.
We call it astronomical units these days.
That's right. It's a fundamental unit which we try to measure. It turned out to be extremely difficult measurement to do, or these days can do radar observations. It can do bounce radar waves of the planet Venus, for example, and get measurements to really few meters or probably even few centimeters in distance. But in Cook's time, they had to do the timings just as Venus moved onto the disk of the Sun and just as it moved off the disk of the Sun. And that turned out to be a very difficult measurement. And Cook and the astronomer Charles Green were both rather upset because they thought they didn't do it well. It turned out other people doing observations elsewhere had even more problems. They actually turned out to be one of the best observers of the transit in 1769.
And of course, it was after observing the transit of Venus that Cook opened his secret orders. These were sealed orders, which he wasn't to open until after the transit of Venus was complete. And he then opened those orders, and that's when he found out his next mission was to circumnavigate the east coast of Australia.
He deliberately went looking for the east coast of Australia. It was already well known to, obviously well known to the people who lived here, the indigenous people, but it was also well known to the Dutch, who mapped most of the western parts of the country. The only part that had not been mapped is the east coast. And Cook took the deliberate decision after he had followed orders, circumnavigated New Zealand and mapped New Zealand to return home via the east coast, the unmapped east coast of Australia, mapped the east coast, and as he sailed up the east coast, he took very careful observations so he could chart the east coast, and he named a lot of the features around there, places like Point Danger, Mount Warning, Whitsunday Passage, Magnetic Island, Green Island, all named by Cook and used to this day.
Was he one of the world's greatest all-time navigators, do you think?
I would think so. I would think he really did extremely well. He was one of the first people to be able to navigate accurately. He did not have a chronometer on his first voyage, on the voyage that reached Australia, but he navigated by what was then called the method of lunar distances, by observing the angular distance of bright stars from the moon. And he had tables from Greenwich Observatory, their first nautical almanacs, which gave the time at Greenwich when particular stars were at certain distances from the moon. And by doing that very accurately, he could then work out the time at Greenwich, compare it with the local time, and then work out how far east or west of Greenwich he was.
That was all part of the big longitudinal
question. That's correct. So he was really one of the first explorers who had available to him the astronomical almanacs from Greenwich Observatory and the method of lunar distances, so he actually could work out his longitude at all times. Latitude, the other coordinate needed to find his position on Earth, was relatively easy to measure, but longitude was very difficult, and previous explorers did not really have accurate longitude, but he had both longitude and latitude, so he could make very accurate charts. That's why he has very accurate charts of the east coast of Australia, and he could find his way relatively easily. In the Sky Guide, we not only talk about Captain Cook and the 250th anniversary of his arrival, but it's also a section on what the sky was like the night before he arrived, what the Aboriginal people, the local, the Gadigal people who were there in around what is now the Sydney area of the east coast, what they could see. And one of the things that they could see, of course, is the very famous star constellation of the Aboriginal people, the Emu in the sky. And there's a beautiful photograph that my colleague Jeff Wyatt has taken, and he actually wrote the section, and a very beautiful photograph of the Milky Way. They can very clearly see the Emu in the sky made out of dark lanes in the Milky Way.
That's Dr. Nick Lom, Consultant Curator of Astronomy at the Powerhouse Museum's Sydney Observatory. The 2020 Australasian Sky Guide's a great companion if you're checking out the night skies. We use it as a reference source here on SpaceTime. And because it's written in such an easy-to-understand manner, it's a great way to get kids interested in science and the universe beyond their social media accounts. The 2020 Sky Guide's available from the Powerhouse Museum, the Sydney Observatory, and online at mwaas.museum/store/. And this is SpaceTime. I'm Stuart Gary. And time now to take a brief look at some of the other stories making news in science this week with a science report. The World Meteorological Organization says the year 2019 ends a decade of exceptional global heat, retreating ice, and record sea level rises, all driven by greenhouse gas emissions from human activities. In fact, scientists found that between January and October this year, the average global temperature was some 1.1 degrees Celsius above pre-industrial levels. They've also found that the atmospheric greenhouse gas carbon dioxide hit a new record level of 407.8 parts per million last year, and it's continued to rise during 2019. The organisation warns that if people don't take urgent action now, the planet is heading for a temperature increase of over 3 degrees Celsius by the end of the century, and that will result in ever more harmful impacts on human well-being. The big problem remains the Paris Agreement. It's designed to keep the increase in global warming to around 2 degrees Celsius by the end of the century. However, it also allows China and India to keep increasing their rates of carbon dioxide emissions, with China alone increasing its annual CO2 emissions output by an amount greater than Australia's total yearly emissions of greenhouse gases. A review of studies has found that 1 in 4 children and young people are using their smartphones as a way which is consistent with a behavioural addiction. The findings, reported in the journal BMC Psychiatry, are based on data from 41 studies published between 2011 and 2017. The review found that across the studies, between 14 and 31% of kids and young adults had problematic smartphone usage, and that this was linked to an increased likelihood of depression, anxiety, stress, and poor sleep quality. A new study suggests gender dysphoria, a state of extreme distress caused by feelings that a person's true gender doesn't match the one assigned to them at birth, could be caused by changes in the network neural activity of a person's brain rather than an incorrect brain sex. The findings, reported in the journal eNeuro, claims a major theory of distress in gender dysphoria was based on the idea that these individuals have brains with sizes and shapes more closely matching the opposite sex to their gender at birth. However, the authors of this new study say that it may well be the result of functional differences in the distress, social behaviour, and body ownership networks of the brain, rather than differences in the size and shape of the brain. They believe this theory could offer new ways to treat the distress of gender dysphoria patients without relying on invasive and often irreversible gender reassignment surgery. Archaeologists have discovered colourful ancient Jewish mosaics at a dig site on the Golan Heights. The mosaic fragments were uncovered during excavations of a rare 3rd century Roman period synagogue. The discovery is important because synagogues underwent a transformation between the 2nd and 3rd centuries from a place specifically devoted to learning, hence the term shul, German for school, to sites for communal prayer. In the process, 3rd century synagogues saw a transition from the unadorned style used for the Second Temple in Jerusalem and newer elements which over time became commonly found in prayer halls, like colourful mosaics featuring animals. Scientists from the University of Haifa who made the discovery say the temple's halls featured floors decorated with geometric designs, while mosaics including images of animals were laid down to ornament the main room. The Roman Empire's decision to banish the children of Israel from their homeland 2,000 years ago saw the Jewish presence in the Golan Heights suddenly cease to exist following what had been thousands of years of settlement. This means 3rd century finds such as this are extremely rare. A new study has found that some people are better than others at deciphering subtle differences in cats' faces that reveal their mood. A report in the journal Animal Welfare says the study recruited more than 6,300 people from 85 countries who were asked to watch 20 short online videos of cats from a collection of 40 videos gleaned mostly from YouTube and then complete a questionnaire. The videos showed cats experiencing either positive emotional states, such as being petted or given treats, or negative states, such as experiencing health problems or being in situations that made them retreat or flee. Each video was focused on the cat's face, its eyes, muzzle and mouth. None of the cats showed expressions of fear, such as bared fangs or flattened ears, as these facial expressions are already widely understood. Participants were asked to judge whether each cat was in a positive state, a negative state, or if they weren't sure what state the cat was in. Most participants found the tests challenging, with an average score being just 12 out of 20, and that's not much better than chance. But 13% of participants scored 15 or better, a group that researchers informally referred to as cat whisperers. These people were more likely to be female rather than male, and more likely to be veterinarians or vet technicians. Younger adults also generally scored better than older ones. The authors say the fact that women generally scored better than men is consistent with previous research that shows women appear to be better at decoding non-verbal displays of emotions. Surprisingly, being a cat lover made no difference at all, since reporting a strong attachment to cats did not necessarily result in a higher score. The findings are important because they could help strengthen the bond between owners and cats, and could also improve cat care and welfare. The Pacific Island state of Samoa has declared a state of emergency, ordering all government offices, schools and the National University to be closed as a deadly measles outbreak continues to spread. The outbreak has already killed more than 63 people, most of them children. In response, the government's ordered mandatory vaccinations, launching a door-to-door vaccination campaign and asking families to display red flags in front of their homes if they haven't yet been vaccinated. However, government officials say anti-vaxxers have been complicating their efforts to turn the tide on this highly contagious disease, which has already infected more than 4,300 people. They've even arrested one prominent anti-vaccination activist who's now been charged with incitement against a government order. Tim Mendham from Australian Skeptics says it's another example of the real harm being caused by the anti-vaccination movement.
This is really sad, and this is an indication of some of the influence of the anti-vaccination movement. Samoa has closed down all of its schools. The University of Samoa has been closed down. People have recommended that they don't go out and mix with other people because there's been a major outbreak of measles. So this is measles which is affecting kids, and as you know, measles has a very, very infectious and very dangerous virus. It can not only cause death in the extreme cases, but it can cause neural damage, brain damage, various health issues as well. It is not a safe disease to have, even though a lot of you've seen anti-vaxxers who put on measles parties to, bring your kid along so they'll all catch measles. It is not a good thing to do. Now, the problem is that Samoa had a vaccination rate of somewhere between 25 and 40%, which is appalling. You need 95% at least to get the herd immunity, by which measles has few areas that it can latch onto, few people. But at this 25 to 40%, it's gone wild. And the cases have just doubled week by week. So much so that Samoan government is now saying you can't enter the country unless you show you've got vaccination things. The irony is that it might have been started by someone coming from New Zealand, where there has been measles outbreaks, into Samoa, and of course New Zealand's got a large Samoan population, and therefore that's caused the outbreak because of the low vaccination rate. Other islands in the South Pacific, such as Fiji and Tonga, have decent vaccination rates, but they're equally worried because no vaccination is perfect, and even when they have 95%, or in Tonga's case, I think it's 99% vaccination rate, there is still always a danger. And, measles is not wiped out. Measles is getting worse and worse and worse every year, and you'd hate to go back to the bad old days before vaccination, when there was an estimate that about 2 million people died every year from measles. The vaccination has largely cut that down amazingly, and a couple of years ago it was down to under 100,000 deaths, and it's now increased again. It's gone up again. I think there was one particular country in Africa that's had 5,000 deaths recently. We have people coming to us who are anti-vaccination saying, measles never hurt anybody. That's stupid. It's dangerous. And my response is, well, you need to do some research. Oh, sorry, you're an anti-vaxxer. You don't do research.
Why is the vaccination rate so low in Samoa? Is it simply a question of cost?
It is. I mean, it's often a case of access. Developing nations, third world countries, don't have the facilities in place to carry out these programs. But there was a case a year or so ago when 2 children who were having the MMR vaccine, which is the mumps, measles, rubella vaccine, died. And instantly the Samoan government stopped all vaccinations. And the MMR vaccination is amongst anti-vaxxers the baddie because of the supposed link, totally phony link, with autism. And what's happened is that because of these 2 children dying, they stopped all vaccination in Samoa. And as it turns out, it wasn't the vaccine. It was the way it was prepared by a couple of nurses who actually did the vaccination incorrectly. That was what caused these children to die, and that resulted in the government banning vaccination for the time being. And that's partially what's happened now, is that the vaccination rate's low anyway. And now it's opened themselves to people bringing measles in. Australia is technically measles-free because we don't have endemic measles, but we have measles coming in from visitors, whether people are returning to Australia or tourists or whatever, carrying measles, and we are having outbreaks of measles in Australia. So, I mean, once upon a time, a few years ago, measles would have been wiped out entirely in the same way as smallpox was, and suddenly it's made a comeback because of the anti-vax movement. Very sad.
That's Tim Mindham from Australian Skeptics. And that's the show for now. You can subscribe and download SpaceTime as a free twice-weekly podcast through Apple Podcasts, Stitcher, Bytes.com, Pocket Casts, SoundCloud, YouTube, Audio Boom, from SpaceTimeWithStuartGary.com, or from your favourite podcast download provider. If you want more SpaceTime, check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as loads of images, news stories, videos, and things on the web that I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word and in lowercase, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram. On Facebook, just go to www.facebook.com/SpaceTimeWithStuartGary, and you can also find us on the SpaceTime with Stuart Gary YouTube channel. SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.